Good afternoon. I'm at the Redsand Podcast studio in London. My name's Brian Mort, and it's my pleasure to welcome a powerhouse team from Redsand. I'll introduce from left to right. We have Sandeep Dharma, investment banker, serial entrepreneur from Bangalore, now living in London. Welcome, Sandeep.
Thank you, Brian.
Nicole Anderson, former tech and now fintech founder and serial entrepreneur and founder of Redsand. Hello.
Hello.
And Martin Ward, the first West Midlands Tech Commissioner, tech impresario, and a number of boards. Certainly I know you from SAP and Fujitsu, so welcome, an amazing team. And we're here today to talk about inference and compute power with Redsand.ai. So without further ado, Nicole, may I ask you first? You're the founding CEO of Redsand.ai. Tell us what the company vision is and what problem you're trying to solve.
Thanks, Brian. Well, it's really simple. Redsand is here to do three things. Fundamentally, and I think it's on everyone's lips, we want to make AI as safe as possible. We want to make it accessible as possible. And what we'll do today, and I think we'll bring light to the subject, is AI can be a very expensive business, and we're trying to buck the trend. So many people, when they're thinking of AI, they're thinking of this new generation of AI, generative AI, the ChatGPT type model. What few people understand is how much compute power goes into bringing these models to life. And further, what people simply think is when they think of compute power, they think of centralized, isolated data centers that drive this need. Well, that's fine if you're talking about structured data, you're talking about, static bulk updates to data that moves in a straight line. But when you're talking AI, specifically generative AI, you are really looking at living, breathing IP. Every nanosecond, a model is changing. The logic is evolving. And that crunches a huge amount of data. So we've turned the model on its head, and we're looking to bring data to the users in the most accessible way in order to deliver the fastest response needed. And as AI adoption grows, so the physical layer is going to have to be distributed. That's what's known as edge. And the logic between the user query to the model is what is called inference. And that's our speciality.
Super, thank you. And I can imagine this is largely not unbundled as a service, as we see, with our knowledge of all the big cloud players, it's one size fits all.
Yep.
So very interesting. Sandeep, may I ask you then, what is inference? We keep hearing about this term. Could you describe it for us?
So what is inference? If you look at an AI model, and if it does anything, we can call it inference. I can explain it like in a simple way. If you look at it, training is when you teach the AI model to speak, and inference is when it starts speaking, forming sentences, and it starts giving you speeches and things like that. And inference happens all the time. Training is a one-time exercise. You build a model and it's all ready and it's done. But when you start deploying this model, you start interacting with real users, and each user, every time they use a chatbot, they put an image in, they generate a video, you run a fraud check for a bank, any use case you take up, each of those instances creates an inference request on the server. So inference happens all the time. And if you imagine millions of customers across an enterprise, they start using this on a daily basis. Every second counts. So it's happening all the time, and it becomes really expensive for AI models as they start running on the cloud. So this is where a lot of big enterprises as well as startups don't envisage what's happening, and then you're set up for failure, I would say. Yeah.
So corporations are building and training their large language models, And you're talking now about the really critical piece, the speed, the last mile. It's even less than a mile, it's the last yard or meter of having a service from AI. Is that right?
Yes. So when you look at the traditional cloud model, right, the cloud was never built for AI really. The cloud was built for storage, and sometimes you may access it, sometimes you may not. But what happens in the AI model is every time there's a query, you access this. And the farther away you are from the user, the more expensive it gets. The cloud model is based on a model where you get charged for compute, you get charged for storage, you get charged for moving data in, moving data out. So every time you have a query, you get charged for all of this, and it's a ticking time bomb. As you grow the number of users, your budgets could explode. And we have already seen a lot of instances where enterprise use cases as well as startups, the cloud costs have gone from whatever they were there pre-AI to now 5x in terms of whatever they're spending on the OpEx. So that's a big element that a lot of enterprises don't factor into their budgets, which is where you will see this implosion happening.
It's like moving into a very large house and not factoring in your winter fuel bill.
Yes, absolutely.
Incredible.
Yeah.
Martin, let me ask you. You must be asked on many boards in the world, and I know between the US with businesses that you're advising and over here in Europe. Why did you join Redsand?
Well, good question, Brian. Well, first of all, I have to say, directly linked to Nicole, we both served on the UK board of SAP, which is where we first met a while ago, I have to say. But I've always had the greatest respect for Nicole in the corporate world, and I've tracked her entrepreneurial journey, and it's been very impressive. So when she called me up and gave me the opportunity to help with the business development, I jumped at it. The other point really links to what Sandeep just said. I've seen many shifts in the infrastructure paradigm over my career. So when I started, we all had mainframes, and then we had departmental computers. Then we moved to more of a service model with managed services, and then it went to a full cloud service. And actually, we're right on the precipice of needing a new paradigm for AI, which is exactly what Sandeep talked about. So I think we are right at the start of the next revolution on infrastructure, and it's a very exciting place to be. So that's the fundamental reason why I think this business is in exactly the right place at the right time to do very special things.
Super. No, thank you. Nicole, let me ask you, as part of the stack that you're building, the sovereignty of data, the security of data in all of this. We've come from, as Martin says, the mainframe to client server to cloud computing, and now agentic software, and all of those stacks and APIs have to link together for the corporation to be able to use its data. That's if it can use its data according to its licensing with its major vendors. But talk to us about data sovereignty as part of this. What does it mean, and how are you tackling that?
So sovereignty is a term I think is misunderstood. So from an AI perspective, it really boils down, the best definition is, are you in control not only of the data, but what the model is doing with the data and the distance between the data input, the model doing its thing, and the user receiving the output. So that control loop is really what is referred to when it comes to sovereignty. And you'll see the word sovereignty and AI being used almost interchangeably and certainly connected in every major conversation around safety. And AI is unsafe in the wrong hands, desperately unsafe. So we see these examples of, this is way beyond what we call just privacy. We're now starting to look at this virtual lock and key having to extend in different paradigms. So whether that be an individual user, whether that be a company operating safely, or within the guise of AI regulation, not really even here yet. And then, of course, at a nation level, of course, every country around the world has an AI strategy, plan, policy in some shape or form. So very very important topic. Well, we've been really lucky in as much as we came out the block, so to speak, with decentralized thinking. And our drivers were, well, we want to make AI as accessible to anyone. And in fact, our major origins for our thinking were based on access to energy, which of course is still a huge friction point on the supply side. So as a consequence, we came out being able to build capacity very lightly. Think of IoT. I mean, that would be a brilliant use case for us when it comes to AI. Because we decentralized and physically decentralized, we can capture what is required from a privacy stack, both at the physical layer and the software layer. And so it makes it very easy for us to localize the AI use. So if a business or a bank or a government department need to ensure that their data is localized, we can be in the cupboard next door. Right. And that is what we mean by hyperlocal and as safe as houses, so to speak.
Brilliant. And customers and partners that you're speaking to, I imagine, want their data in the cupboard, in their building, in their country.
It's the most ironic thing, as you say. I mean, we've all had technology careers where the big drive, as Martin said, is kind of to move from mainframe through to, on-premise and then into the cloud. And we're seeing this hockey stick boomerang, I think is probably the right sporting gear to refer to, of people go, you know what, I'd rather just go back to basics, and I want my data as close to me as possible. So yes, we are seeing use cases where we can provide very, very light touch compute for, a small use case right through to basically a modular data center in a garage, all right, or on a rooftop or in a car park. And that is why we talk about being hyperlocal with AI.
Just on this sovereignty point, actually, I talk to a lot of law firms as an example. And what we're actually seeing is that there's a lot more focus now on the intellectual property, the knowledge base that's in the company, and very significant concern about this leaking out into these LLMs. And if that happens, then essentially you've lost your fundamental competitive differentiation. So there are certain sectors, particularly knowledge-based sectors, that are right at the front of this privacy and sovereignty requirement that Nicole talks about, because it actually will be critical to their future. Because if they do bleed their IP out into these LLMs, they've lost it and they can never get it back. And that's where sovereignty becomes very practical. It's a matter of business success and survival. The flip side, of course, is if they can harness that intellectual property in the form of private LLMs that they can make available in a structured way, so they have the data sovereignty, then they can capitalize on that IP, which is exactly what they need to do. So it really is a very practical challenge. And it's not about security as we might have considered it. That's part of it, but it's actually around ownership of intellectual property assets.
This is an incredible kaleidoscope of managing data, IP, security for your global corporation.
Yeah, and we've all heard about the DeepSeek leak, right? So, here you have a major data leak in a public cloud, where IP was used by essentially a competitive large language model in a part of the world that wasn't necessarily considered that favorable. All kinds of commercial benefits of doing that, having to basically train a model on a sophisticated model like OpenAI's ChatGPT, it has had huge ripple effects throughout the world. And so not for 1 minute are we saying that public cloud isn't secure, but I think the perception in many users' minds is now become reality, and therefore the default is, I'm not taking any risks.
Yes.
So, and just to add to what Nicole was saying, right, the DeepSeek example actually showed what happened there was that you can't have two major competitors sitting in the same facility. Physically, they have to be air-gapped and they have to be separated. And if you go with the traditional cloud model, this is not possible. So the cloud thrives on scalable, compute. So it has to be big, massive. That's how they're able to offer their services. This is all well and fine when you're just doing storage and you're just retrieving when you need them. But then when you have this AI model sitting there, it's like a monster that's eating up all the data that's there, learning from it, and then evolving again. So this is the other challenge that infrastructure players also have to look at. They can't really go with the traditional model. You have to think out of the box, and even if it goes to going back to basics, build from the ground like we are trying to do, build modular, build on the edge.
Talking of eating the budget, Sandeep, inference costs, I know, as the financial lens on all of this. Why is it so expensive, and why is it not costed into the technology stack?
So this again goes back to the traditional cloud model. So the cloud was built on, you could assess the demand well ahead, and you could say, this is my storage demand for the next 6 months, 1 year. I have all this data, you store it, and this is what it's going to cost. So but enterprises were very happy with this situation. So you knew budgets. And cloud also went with the concept of how they could save a lot of money compared to building it on premise. You don't have capex, you only do opex. So that was the model. When you bring the element of AI in, like I said early on, inference is a living and breathing organism. So it keeps on generating a lot of information, and every call to the model triggers a lot of technical points where you will have to pay for the compute, pay for the storage, pay for the network. And the farther you are, the more expensive it gets.
Mm-hmm.
So it's all well and fine. You will see enterprises when they start up, or even startups when they start working on AI models, you have a model which works very well. You have built a use case based on that, and then you launch this model out. You have factored in that, this works well. I know my budgets. I'm paying X for each of my call to the model. So it's all working great. But then you have all your users who have gone excited about this. Take the case of the Ghibli image generation phenomenon that happened a few months ago with ChatGPT. Literally, it burned all the servers that they had because they couldn't take the demand. So if you're on the other side, if you're ChatGPT now, or if you're OpenAI, who's the owner of ChatGPT, how do you factor in the costs of all this infrastructure? You can't really anticipate what the customer wants. And if you're in a model where the cost or the price you pay is based on your usage, and you don't know what's your usage or it's unlimited, you could have a situation where you estimated that your cloud bill is 10,000 a month, and you could get a bill from AWS or any of the other cloud players tomorrow saying that we need 500,000 right now because your users are getting excited and your model is doing well. So you start paying the price of your success in your OPEX, which is critically not what happens in a SaaS model, but this is how it's happening.
And interestingly, to build on that point, if you look at some of the recent research around AI native businesses, it can be up to 60% of their operating expenses going to service their cloud infrastructure. Well, you then put an investor's lens on. If you're a venture investor or PE investor and you're putting investment into a native AI business, which many of them are doing, well, a lot of that's just going straight out the door to service the actual models. So cost becomes a massive challenge. And actually, as we've been looking at all the plethora of use cases for Redsand's technology, we have been talking to a lot of PE houses and venture funds where there's opportunity either to reduce the costs for those ventures so they make more profit and therefore they're worth more, or actually to convert some of the value they offer into provision of compute as opposed to simply cash. And we're actually seeing those sorts of models appear in the market. So you're seeing very practical considerations about the financial cost of applying a pure large-scale cloud model to an inference challenge, and that's only going to get the pressure's going to build more and more over time.
Like
that's not going to go
service.
Exactly so. Yeah.
So Martin,
sorry to add to it's very close to our hearts because we're a young business in terms of our journey, but we've been, individually, we know we've been through multiple generations of technology. So wisdom does count for a lot in an industry that is so nascent. And along with the boom in AI, and I would call it the kind of application layer of AI, not only have we seen this like hemorrhaging of really precious early capital going to compute, which is absolutely just crazy from an investor perspective. but we've also seen let's call it a level of irresponsibility of or ignorance or blind ignorance, where younger companies, or not so young companies, have utilized this kind of mid-market solution for infrastructure. So because of the shortage, it's solved now, but the original shortage on semiconductors, what you saw developing was this arbitrage model in providing compute between those that had the compute and those that needed it. So we call it like cloud brokers developed. And so what was happening is companies were just deploying money into middlemen, so to speak, in the industry to find them compute wherever it was. We've just touched on sovereignty. There is a direct line between the GPU and the model. And we've just hopefully explained the dangers of not having that as assured capacity. So not only has a lot of money gone out the door, but these young models where all their IP is really the investors are betting on that IP is potentially having exposed in terms of leaks because they don't have guaranteed compute.
Gold rush and picks and shovels comes to mind.
Yeah.
I wanted to ask you, maybe Martin, I think you've delivered some of the most important, largest projects in the world with SAP and Fujitsu. What kind of companies are the early adopters here? Are they the usual ones? Who's adopting this faster with the technology and the gold rush that's been in place the last 12 months?
Well, you've obviously got a whole class of AI native businesses. There are many, many of them. And you always see this when there's a shift in the technology capabilities. You see a new industry S-curve. So you see in an early marketplace, you say the picks and the shovels, it's very much Wild West. So you see many, many native AI businesses cropping up. So that's obviously, they're in many ways leading the way. But we are seeing enterprises, well-established enterprises, start to grapple with the opportunity and the challenge of AI. From an industry's point of view, financial services, for example, is an early adopter. So you imagine in, say, the insurance sector making a sophisticated decision about whether someone is insurable, and you need to make that decision in real time often. So the latency issues around inference become very challenging. So there's a clear drive to adoption there. If you look at the constraints around the sovereignty model, where we've talked about knowledge-intensive industries, so legal, professional services is a key area, and also healthcare, of course, where you've got very significant privacy concerns as well. And on the cost side, it's sort of everybody. So everyone's focused on reducing what have become very significant costs.
So I think, when we look at this tornado of change and we look at the performance and the differentiation, talk to us about how Redsand makes that difference amongst all of the hyperscalers that are out there. Nicole, maybe a question for you.
Yeah, the dreaded term hyperscalers, which I have to say from the outset, we have been forced to, because we're in the compute game, have a default comparator. So, conversations is like, well, who is your competition? And yes, I guess in the early days where supply was short, and it made sense to train models centrally in one location, okay, fine. They would be the natural default. But we work, hopefully from this discussion, you can see we would be, we're in a different dimension. So we're very complementary to centralized compute. The two being able to deliver close to the user for all the reasons we've discussed here today, along with this, monolithic requirement to keep on feeding the compute power for, large training of models. The two have to work together. So they have their place as we do. We are hoping to be the disruptors in as much as, we can work with any infrastructure. And it is our aim to be agnostic on the technology. So we're providing the service. A customer who uses us has the freedom to evolve their configurations, their requirements over time. to pull us through wherever they may need to go in the world. And think of, pins dropping on a map, right? On a Google map. That's really our model, is to kind of follow the wave with the most agile physical layer as possible.
And so right sizing, perhaps, Sandeep, you've talked about that. Describe that in a little more detail for us, perhaps.
Yeah, so right sizing. What we mean by right sizing is we give what the customer's use case demands. So we build the configuration based on the chatbot or the use case that they are evolving with. This is different from what the cloud players currently do, where they give you a huge configuration and you just run a simple chatbot, but you still end up paying for all the compute that's wasted anyway in the configuration. So we try to understand what the customer needs and build that specific configuration for them. Nothing more. It should be optimal for what their current needs are. And if their use cases evolve and they have more demand, we could always scale up according to whatever is their rollout.
Like a Lego.
Like a Lego, yes. So it's literally a modular play that we work on. And this comes with a fixed price. So the other innovation that we are bringing back, maybe it's not really an innovation, it's going back to basics again, that you get a contract where you have a fixed monthly price. So for the next year, 2 year, 3 year, as long as the contract exists, what is the price that you're paying for this? It's irrelevant with your usage based on the configuration, which is something we feel that will work very well in this market, because enterprises fix their budgets long before they actually start using them, right? So this would be an ideal scenario for that.
So you could start, after your sizing with a small or medium size solution, and then build on top of that, keep the medium, go to a large or an extra large.
Yeah, that's a very easy way to think about it. I mean, if you want to start small, start small. Tomorrow, if you want to build an extra large one, we could always scale it up in a matter of weeks, not even months. And we can go global. We can deliver, like Nicole said, anywhere in the world, as long as the customer is happy and they know what is their configuration that they need. We could also help them with the configuration. We are also not fixed to a particular hardware brand or the semiconductor madness that's going on right now. So we really configure based on the customer. So it's a customized solution that we try to offer. And the pricing is also bespoke. So it's tuned to what you need.
Yeah, I mean, I think the challenge, many challenges with the infrastructure industry is that there is a huge gap in terms of, I'm a business user owner, right? I'm a multinational. I do not want to be labored by heavy capex burden, or even understanding, the ins and the outs of what's behind that capex. I want to switch on my capacity, and I want it to be safe, and I want it to be available. That's the ultimate aim here, and that's where it should be. I think, like any new industry, everyone gets lost in, the next announcement from NVIDIA, which is amazing, fantastic. But as a business user, it means zippo. It means nothing to me. And so, we're bridging the gap. We're trying to, we probably also, as a differentiator, I have to kind of have a self-plug. I think we're one of the few players in infrastructure that really know how to deal from a business requirement right through the software layers to the infrastructure. And that's unique. That is definitely our advantage as well.
I would imagine the microscope of the CFO office looking at the cost of ownership, the return on investment, is a very difficult thing to articulate, right? If you're a business, Martin, you mentioned real time. I was going to come back and ask you that if you're in real time with your customer, and you need to articulate that, it's all about the latency that you mentioned. So how does that get articulated in terms of a value to a business?
So I think one of the important things to say, there is a unique positioning for Redsand, but it's also not. This isn't an anti-cloud play. It's about complementarity, to be honest. And the way I like to think of it, you touched earlier on the last mile problem. Mm-hmm. And if we look at that, say, in broadband, the big telco operators, BT in the UK and others, they could get sort of close to the individual point of consumption, but they couldn't get over that last mile because the economics just didn't work for them. And actually, those economics do work for the play that Redsand has. And it's actually fixing that last mile problem for the AI inference industry. So, you can see and imagine a Google, a Microsoft, an Oracle bringing huge data centers, perhaps even down to a city level. But it's hard to imagine that they're going to put AI inference capacity literally right at the point of consumption, which is where we need it for the certainly the latency and the sovereignty. So I think there's this whole layer to the industry that doesn't exist yet, and that's exactly where Redsand will fit. And I use this analogy of sand in a jar, actually, which I've talked to Nicole and Sandy about a lot. And you take a jar, you put some rocks in, you put some pebbles in, you pour some sand in, and you realise the sand actually has the same volume as the rocks and the pebbles. And Redsand, beautifully named, of course, is very much that sand. It's filling in all those little gaps, getting inference to exactly the point of consumption. And that's actually territory that the global hyperscalers, their business model is not going to enable them to go there. So it is very much about a complementary play to meet the needs of the end customer. I think that's a really important point to make.
Yeah. I'm going to come back to you then maybe on the cost of ownership model for, a particular industry space, Sandy. Perhaps you could answer around, the inference, the latency side. Let's say for a bank, if you're looking at fraud checks or KYC, how does a global financial institution look at this?
So that's a very interesting use case, the banks, right? The fraud detection as well as payment mechanisms that go around. It happens in real time, and you have millions of transactions happening on a daily basis, or I would say billions also. Most banks use AI these days to detect any fraud, any anomalies in the system, and they can then action it on a real-time basis. If you use the traditional cloud model, most of the data flowing in and out will again get charged, like I mentioned previously. So it becomes incredibly expensive for you. That's one. And the second one is the latency. So what is latency? Latency is the time that is taken to process this and get back to you. So if you send a query and the query has to be processed and you get back the reply from the model or whatever is the actionable insight, that time that's taken is what you could generally define as latency. And the longer it takes, the more difficult it becomes for the bank also, because you will have to make approvals in real time basis.
You could lose your customer.
You could lose your customer.
Your application.
Or get it wrong.
Yes.
It could be. So
Yes.
I think it translates to risk as well.
Yes.
It's lost business. It's risk.
Yes.
There are many business drivers which are touched by latency if you have a real time industry.
Yeah, and then customer satisfaction goes
Of course.
away, and you have a lot of these issues. That's on the latency side. And then the third most important point is the compliance issues. So as a bank, you need to keep your data within a certain radius or inside the country, inside the zone, inside your own system. And this is where it becomes mission critical to have this data processed inside your own infrastructure. What we try to do is we build everything inside the bank's own infrastructure. So the data stays inside their own infrastructure. They don't interact with the external world for sensitive data that is passed on. And this is very important in markets like the Middle East, India, and the EU also, with the new AI bill that has come through. The data has to stay local. You cannot pass it outside boundaries. And in fact, in certain countries like Saudi Arabia, we are seeing banks don't even want to go to the public cloud for any of the data. So this demands that either you put up your own infrastructure or you have to go with a service that actually does that for you, which is where we are a shoe-in, I would say.
Thank you. I think you've helped Redsand, the three of you, to unpack, as they say, demystify some of the areas and unbundle the complexities that we face and corporations face today as they look forward to adopt AI. How do people get in touch with Redsand?
Oh, that's really simple. We're not hard to find. So you can find us. Our website is www.redsand.ai. You can email us at hello@redsand.ai. And we have a very active LinkedIn page as well. So, yeah, please come and find us.
Well, there we have it. In summary, I think it's been really helpful to understand latency, sovereignty, security of AI in the Redsand layer. So thank you once again, folks of Redsand, and hopefully you can get in touch with them very soon. And I think you'll be publishing this to YouTube and LinkedIn.
Yes, correct.
Super. Thank you so much, everyone, for listening.